In our previous screencast on functions, we've emphasized the notation associated with functions. However, we cannot forget that not all relationships between inputs and outputs are functions. To be a function, each input has to have only one output. It must have only one output to go with it. So what we want to do in this screencast is look at some input-output relationships and see if we can figure out if the output is a function of the input or not. If it's not, then you would not use the function notation. So let's take a look at this table here. Does each input x have only one corresponding output y to go with it? Well, the input -2 only has the output 4 to go with it. The input -1 only has the output 1 to go with it. The input 0 has only the output 0 to go with it. The input 1 only has the output 1 to go with it. And the input 2 only has the output 4 to go with it. So for this input-output relationship, y is in fact a function of x. So we can say the answer is yes here, and we can actually use the function notation. Y is equal to f of x. The most common reason that students sometimes think that this relationship is not a function is because, for example, -1 and 1 have the same output. They both have the output of 1. But it does not say up here that each input must have a unique output. Unique is not up here. So two different inputs can share the same output. That's fine. It's just a particular input can't have two different outputs. That would be a problem. Take a look at this input-output relationship. The input 4 has the output -2, but the input 4 also has the output +2. That input of 4 has two different outputs. That can't happen with a function. So you would not use function notation here. No, y is not a function of x in this case, so you would not use the function notation. Let's check out this third input-output rule represented in numeric form. The input 1 has the output 4, the input 2 has the output 7, the input 3 has the output 10, the input 2 has the output 7, and the input 6 has the output 19. Now notice that I said 2 here twice. However, 2 has only one output. 2 has an output of 7, and it's just repeated here. 2 has an output of 7. Suppose somebody bought 2 of one item and they were charged $7. And then another person bought 2 of the same item. They were also charged $7. So that's fine. If they were charged a different amount, meaning if 2 had two different outputs, that would be a problem. But 2 only has the output of 7. So this is completely okay. So yes, this y is a function of x here, so we can write that in function notation. Yes, y is equal to, and just to switch it up so it doesn't look exactly like this, I'll write it as g of x. We also want to be able to tell whether an input-output relationship is a function based on the graphical representation of that input-output rule. So we've got 3 graphs here, and we want to know, is the output a function of the input? And in this case, because we're using the variables x and y, we could say, is y a function of x? Remember, each input must have only one output. So let's take a look at a bunch of inputs for this first graph. This input of 1, notice if you go up to the actual curve, it has only the output 1. So that input has only one corresponding output. How about this input of 2? Well, if you go up to the curve, notice it has only one corresponding output, particularly 4 in this case. Or what if we took this point right here? If you go up to the curve, it has only one corresponding output with it. So if you were to continue to do this, you see that each input has only one corresponding output. So in this case, yes, y is a function of x, and we'll call it y equals f of x. Let's take a look at this graph over here. Let's take this input right here of 1. Now for this input, if we were to go to the curve, notice it's got 2 points here, meaning it has two different outputs. In this case, the input of 1 has an output of +1 here, and the input of 1 has the output of -1 here. So that means this input of 1 has two different outputs to go with it. Hence, this is not a function. So no, y is not a function of x, so I would not use function notation to represent this. But now, what we want to do is we want to generalize this idea of each input has only one output when specifically looking at a graph. So over here, each input had only one output to go with it. Whereas right away with this one, this input had two different outputs to go with it. So we want to focus on this idea right here. And we can summarize what's happening here. If you can draw a vertical line and it hits the curve in more than one spot, then it is not a function. This insight is so valuable, we have a special name for it. It is called the vertical line test, or often referred to for us as VLT. So the vertical line test says if any vertical line touches it in more than one spot, if any vertical line, and specifically vertical, if any vertical line touches the curve in more than one spot, then the output is not a function of the input. Then the output is not a function of the input. Otherwise, it is a function. Otherwise, it is a function. So let's see if we can apply this vertical line test without having to pick out particular inputs to see if there's only one corresponding output. So if I were to draw vertical lines over on this very first one, do any of these vertical lines hit the curve in more than one spot? This one only hits here, 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 here. And you can't imagine if this curve were to continue like this, you can't imagine a vertical line actually hitting in more than one spot. So by the vertical line test, we can say that y is a function of x. Our reasoning now, we don't need to say each input has only one output. We can say yes, by the VLT, y is a function of x, and meaning we can use this notation y equals f of x. Over here, if we draw a vertical line, this one right away hits in more than one spot. So that means by the vertical line test, y is not a function of x here. So y is not a function of x here. How about this one? If you draw a vertical line, are any of these vertical lines going to hit the curve in more than one spot? Well, this first one only hits here. The second one only hits here. Third one only hits here, 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 here. And if this curve continues in the same way, we've got this straight line here, are there going to be any vertical lines that are going to hit the curve in more than one spot? The answer is no. So that means y is a function of x here. So yes, y is a function of x by the VLT, or the vertical line test. And we can then, of course, use the notation. So y is equal to, let's say, g of x. To summarize, the definition of function is that each input has only one output. But when you are looking at a graphical representation of an input-output relationship, you can see if y is a function of x by using the vertical line test. And if any vertical line touches the curve in more than one spot, then the output is not a function of the input. Otherwise, it is a function. So the vertical line test can be used in place of the definition of function when you're looking at an input-output rules graph to see whether the output is a function of the input.